Question 1. Write 7,357 to three significant figures. Well, that's the first significant figure is to the nearest 1,000, to the nearest 100 is the second, so it's the nearest 10, and the 7 will round this up to be 7,360 to three significant figures. For part B, I'm going to do the numerator first. So I'm going to write square root, open bracket, 17 plus 4 squared, close the bracket, and that gives me root 33. And then underneath the denominator, 7.3 squared, 53.29, and then I'm going to do the calculation again as I see it, so root 33 divided by 53.29, and that gives me 0.1077981356, and that's all the figures on the calculator display. Question 2. Last year Jo paid £245 for her car insurance. This year she has to pay £883 for the car insurance. We've got to work out the percentage increase. So the first thing I'm going to do is look at how much it's increased in terms of the money. So I'm going to do on the calculator 883 minus 245. So that is £638. Okay, so just going to show the examiner what we intended to do there. So that's the first thing. And then I'm going to compare that with where we started. So I want you to think about this really carefully, because normally if something went from 3 to 4 in terms of pounds, that would be an increase of 1 compared to where you started, which would be a third or 33.3 recurring percent increase. So this time, I don't want you to get confused. I want you to think, well, this is the increase, so this is on the numerator, and I'm comparing it to where we started, 245. So it might seem a bit strange, but we're going to do that. And as a decimal, I get 2.604081633. So what we have then is a 260.4% increase, and that's just a one decimal place I'm going to give that. Okay, so if something goes by 2.6-fold as a multiple, that's 260%. Okay, so don't be tricked by questions where it's more than 100%. They can happen. Question 3. First of all, we're going to complete the table, and it's y equals x squared plus x minus 4. So for the first one here, that's going to be negative 3 all squared, which you can do on your calculator. I would put the bracket in if I was you. Plus negative 3 minus 4, well, that will be 9 minus 3 minus 4, which is 6 minus 4, which is 2. For 0, we're going to have 0 and 0, which is 0, so we're just left with negative 4. For 2, we're just going to have 2 squared, add 2, take away 4, which is 4 and 2, which is 6, take away 4, which is 2 again. And then for 3, we're going to have 3 squared, which is 9, plus 3, take away 4. This gives us 12, take away 4, which is 8. Some of you may have a calculator that can store values and put them in and give the answers in a table. That's absolutely fine, but I'm just going to do each one in turn, which I think most people would. just be careful with this negative one here, because some people might just put -3 squared in the calculator, and some calculators will return -9, which will be incorrect. So be careful for that. So for the next part of the question, we're just going to do the graph. So we're going to plot -3, 2 first. So we're going to make sure that we know the scale, because this is 1, it's every 2 spaces is 1, be careful. Okay, so -3, 2 will be here. And then -2, -2. So that's 1, that's 2 there. And then we've got -1, -4. And then 0, -4. 1, -2. 2, 2. And then 3, 8. So 5, 6, 7, 8. And then we're going to join these points up. If I was in an exam, I would turn the page upside down and always join the crosses up underneath the curve. You get a better flow. So I'm going to do that now. Let's have a look what we get. So that would be the graph between -3 and 3 on the x-axis. Let's see what the next part of the question says. It says, use the graph to estimate a solution to x squared plus x minus 4, which is where we started, equal to 0. So basically where I'm going to cross the x-axis, okay? Because it's like having y equals here and then y equals here. So if y equals this, okay, that's what we've drawn, and when y equals 0, that's called the x-axis. When x equals 0, that's called the y-axis. Okay, so we want this axis here, which is the x-axis. So I can see here that one solution would be -2.5, and the other one looks to be 1.6. Okay, so that would be my answer. Just by looking a bit closer, I would reckon that you'd probably have some students having about 2.6 here, about 2.6, because I can see here I may have not joined that up very accurately, but they do give you some kind of tolerance, so I think we're safe to go on that question. Question 4. Fran asks each of the 40 students how many books they bought last year, and the chart below shows information about the number of books bought by each of the 40 students. Part A says we have to work out the percentage of these students who bought 20 or more books. So 20 to 24 is 20 or more, and you can see there that's 2. So that's 2 out of the 40 students, which is 1/20. And on your calculator, you can work that out. 1 divided by 20, that gives 0.05. And you should know that is 5%. If you didn't want to use the calculator, you could have just times top and bottom by 5, and you would have got 5 out of 100, which, as you know, is 5% also. Okay, so 5% is the answer. Now, let's have a look at the next part. It says, show that an estimate for the mean number of books bought is 9.5. You must show all your working. Well, for this question, If we look at the midpoints here, so for this one it's 2. For this one, 9 and 5 is 14, so the midpoint is 7. 10 and 14 makes 24, and half that you get 12, 17 and 22. So what we can look at is the corresponding midpoints. So for the first one it will be 2 as the midpoint, but the frequency was 11, which is halfway between 10 and 12. For the next one, the next bar, we've got 7 as the midpoint, and the frequency is 8, and then so on. So 17 times 6 plus 22 times 2, and then we want to divide that all by the total number of students, which is 40. So on the calculator, I'm just going to do that top row first. So 2 times 11 plus 7 times 8 plus 12 times 13 plus 17 times 6 plus 22 times 2, and I get 380 divided by 40. So divide by 40, and I get the answer of 9.5, which is what we wanted to show. So just to see how many marks that was total for question 4 is 6 marks. So let's move on to the next. Question 5. Lara is a skier and she completed a ski race in 1 minute 54 seconds, and the race was 475 metres in length. So let's have a look at that first. So that's 475 metres in, 1 minute, that's 60 plus 54 is 114 seconds. So what we have is metres per second, and we've just got to do this on the calculator. So we'll do 475 divided by 114. So we have 4.16 recurring metres per second. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700 metre race. Well, speed is distance per time, just like we have here, distance and time. And so if we want to work out the time, then we can rearrange that, and time becomes distance over speed. Now the distance we have is 700 metres. And the speed we've already got from before, because we're assuming that's the same. And that's 4.16 recurring metres per second. One interesting thing to look at is, if you look at the dimensions here, we have metres divided by metres per second, which is the same as metres times seconds over metres. Because don't forget, if we want to times, we just change the sign and find the reciprocal. So we just end up with seconds, and that tells us that we were right to think in terms of time. So you can always check your dimensions. It's called dimensions. That's a good tip. So we're doing 700 divided by 4.16 recurring, and we're going to get 168 seconds. Now 2 minutes is 120 seconds, and that's going to leave us 48 over. So 2 minutes and 48 seconds altogether. Now there is a part B, in case I miss it out. It says Lara's average speed actually increases the further she goes. It says, how does this affect your answer to part A? Well, here are some answers: quicker time, or faster time, or reduces the answer to part A. Okay, so let's move on. Question 6. ABC is a right angled triangle. It gives that AC is 14 centimeters and angle C is a right angle, 90 degrees. And it says the size of angle B to the size of angle A, that ratio is 3 to 2. Now, if you think about it, this is good because it's a right angle. So angle A and angle B together make 90 degrees. And if we look at the parts of our ratio, we have 5 parts altogether. So on our calculator, if we split 90 into 5 parts, we're going to go 90 divided by 5, and that gives us 18 degrees for each part. So we have 3 here, so we're going to do 3 times 18, and that gives 54. And then 2 times 18 is 36, and of course 54 and 36 make the 90. So we've got the angles here, and then it says work out the length of AB. Well, I'm going to use this angle here, doesn't matter which one you use, so I'm going to say my A is 36 here. And I'm going to look at this as my opposite then. This is the hypotenuse, the one opposite the right angle always, and this will be the adjacent. So I've got to work out the length of AB, which is the hypotenuse. So I'm going to say SOHCAHTOA. I'm going to write that down. And then I'm going to say, right, I've got the opposite, but I don't have any information. So it's definitely not going to be these two. So I'm going to have to be left by default with this one. And that would be exactly correct because I've got the adjacent, which is 14, which is I want to use, and I want to find h. So I'm going to use this one. So I'm going to have cos of 36 is equal to adjacent over hypotenuse. I'm then going to multiply both sides by h. And then I'm going to divide both sides by cos 36. So that would give me h is equal to 14 divided by cos 36. Do that on my calculator, make sure it's in degrees. So 14 divided by cos 36. And there's the answer. And that's 17.30495168. And I want it to 3 significant figures. So 1, 2, 3. So that's going to be 17.3, and that's in centimetres, and I'm going to write 3SF in brackets. Question 7. The table gives information about the speeds of 70 cars, and we've got to draw a frequency polygon for the information. So with frequency polygons, you look at the class interval and you find the midpoint. So in this case, 5 is the midpoint with 0 and 10. And the frequency is 14, so be careful of the scale. So it's going to be here. Between 10 and 20, well, halfway, you just add 10 and 20 together, which is 30 and half, so that would be 15. And we want to go as high as 18. And then between 20 and 30, well, that's going to be 25. And as high as 26. And then lastly 35 and as high as 12. I'll do that a bit better. And then all I've got to do is join these up. I'll do it freehand, but you really should definitely use a ruler in the exam. So a straight line here, another one, and then one more. I'll try and get that a bit better. Okay, so there's the frequency polygon. It's as simple as that. Question 8. The diagram shows a solid metal cuboid, and we're given the areas of the three of the faces. They're marked, and the lengths in centimetres of the edges of the cuboid are whole numbers. Okay, so I think a little bit of trial and error, but not too much. We could say this was 15 and this was 3, because 3 15s are 45, but then if you think about it, this would have to be 15, and we can't make 27 by times in 15 by a whole number. So with a bit of adjustment, we could say, well, maybe we could look at this smaller face first and say, right, we could have 5 and 3, and that would give 15 centimetre squares for that face. But if this one's 5, then this would have to be 9, because 5 9s are 45. And if that was 9, then 27 would work, because that would be 3. And don't forget, we already had that there. So that would give us the dimensions that we needed. So we've got a 5, a 3, and a 9. Okay, so that works. And it says, the metal cuboid is melted and made into cubes. Each of the cubes has sides of length 2.5 centimetres. We've got to work out the greatest number of these cubes that can be made. So first of all, why don't we work out the volume of the metal cuboid? And that's going to be the dimensions multiplied by each other. So that's going to be 3 times 5 times 9. So on the calculator, that's going to be 135 centimetre cubes. You're going to have these smaller cubes, so they're going to be 2.5 by 2.5 by 2.5, so that's 2.5 cubed. So they're going to be 15.625 centimetre cubes in volume. So we've got to see how many of those we could have. Well, we just simply have to do 135 divided by 15.625. And that gives 8.64. So be careful, the greatest number of these cubes that can be made is going to be 8, because the 0.64 would not make a whole new one. So the answer that we need to write on the dotted line here, and it's for 5 marks, would be 8 cubes. Question 9. We want to expand this expression. That's x minus 2 multiplied by 2x plus 3 by x plus 1. Well, the first thing I'm going to do is do these two brackets multiplied. So I'm going to do it in a grid. X minus 2, 2x plus 3. So that's 2x squared minus 4x, 3x, and then minus 6. So that's minus 6. 3x take away 4x is minus x, and then the 2x squared. And then I'm going to take this and multiply it by x plus 1. And multiply those. And so we're going to have 2x cubed minus x squared minus 6x, 2x squared minus x, and then minus 6. Then I'm going to add these up. So I've got negative 6 minus x minus another 6. 2x squared take away x squared, that's positive x squared, and then 2x cubed. So we have 2x cubed plus x squared minus 7x minus 6. We now have this expression here. That's y to the power 4 multiplied by y to the power of n all over y squared equals y to the negative 3. Well, if we're timesing, we can add these. So we have y to the 4 plus n all over y squared equals y to the minus 3. And then, as we're dividing, we can have 4 plus n take away 2. So that's the same as y to the 4 plus n take away 2. And that's the same as y to the 2 plus n. So now we can match 2 plus n and negative 3. So therefore 2 plus n equals negative 3. So take 2 from both sides and we have n equals negative 5. For part C, we've got to give our solutions to correct to 3 significant figures. So we'll use the formula. So change the colour. In fact, I'll change this yellow to a purple because it's probably easier to see. So if we have 5x squared minus 4x minus 3 equals 0, then we can say x is minus b, so minus minus 4 is 4, plus or minus the square root of b squared, well, negative 4 all squared is 16, minus 4 times a, which is 5, times c, which is negative 3, all over 2a. You can do some of this on the calculator. I'll choose not to in this case. 2 minuses make a plus under multiplication, and 4 times 5 is 20 times 3 is 60. Now I'm going to do the square root. That's the discriminant, this part here, b squared minus 4ac. That's 76 all over 10. And now I'm going to use the calculator for the first time. So I'm going to do this carefully. I'm going to do 4 plus root 76. I'm going to press enter or equals and then divide by 10. And I'm going to write down what the display is on my calculator. So I'm going to have x is 1.271779789. I'm then going to do 4 minus root 76. I'm going to press equals, divide it by 10. And don't forget, on some calculators it might be more useful for you to put a bracket here, depending on how you're doing it on your calculator. So the answer I get is x is negative 0.47117978887. So if I want my answers to 3 significant figures, I'm going to have 1.27 and negative 0.472, because this 7 here would change this 1 to a 2. And they're both to 3SF, 3 significant figures. Question 10. we have a function f of x equals 4 sine x, 4 multiplied by sine x, and we want to find f of 23. Now, this is degrees here, so that would be 23 degrees. So all we have to write is 4 sine 23 on our calculator. 4 sine 23, and I'm going to write everything on my display. 2924514, and it's to 3 significant figures. So 1, 2, 3, and we're going to get the answer 1.56 to 3 significant figures. For part B, we're given that g of x equals 2x minus 3, and we want to find fg of 34. Well, let's have a look in detail at what we need. We know that f of x is 4 sine x. So you can either find f of g of x first and say, okay, so f takes on the function g, so that will be 4 sine 2x minus 3, and then go to fg of 34. So we'll have 4 sine 2 times 34 minus 3, which is 4 sine 68 minus 3, which is 4 sine 65. Or you can work out g of 34 first, which is 2 times 34 minus 3, which is 68 minus 3, which is 65. And then do f takes on 65. Because what we've done here is we've already worked out what g of 34 actually is, this part, and that is 65. So all we've got left is f taking on that value. So some of you may like that, some of you may not. So we'll just have 4 sine 65, which is the same. So 4 sine 65, and that gives us 3.625 231148, again to 3 significant figures. 1, 2, 3. The 5 does round this time, so it'll be 3.63 to 3 significant figures. Now looking at the last part, we have h of x equals x plus 4 all squared, and Ivan needs to solve the following equation, h of x equals 25. He writes x plus 4 all squared is 25. Yeah, that's fine. He then square roots both sides, and he writes x plus 4 equals 5. Well, if you think about it, if you had to square root both sides, you would undo the square root sign here, and you would get x plus 4. Let's just write that a bit neater, shall we? So what you'd have is, this is fine. You'd square root this, that's fine, but then wouldn't you have plus or minus 5? Because 5 times 5, yes, that's 25. But also negative 5 times negative 5, that's also 25. So I'm afraid he should have written his next step is x plus 4 is plus or minus 5. So that would have led him to 2 cases, x plus 4 equals 5 and x plus 4 equals negative 5. So we've got the first one followed through to the end, which is fine, but I'm afraid he missed this one. So you can say he missed x plus 4 equals negative 5, and therefore x equals negative 9. Okay, and that's what he missed. For this question 11, what I've done is I've already sketched it in advance just to show you what points I thought are relevant. Definitely when you've got tan x between 0 and 360 in degrees, you want the asymptotes, so they will be at 90. You can just do tan of 90, you'll get an error on your calculator, it's not defined. The same for 270. So put your asymptotes in, make sure they're parallel to the y-axis. I then put 1 and -1 here. You may wonder why. Well, I thought, I know tan of 45 is 1, so that gave me a little bit of idea of how this curved, okay, how to start it off. Likewise for 135 and so on, so I knew these were all at -1, 1, -1 and so on. So I also made sure I showed that the curve was tending to the asymptote but not actually cutting it at all. That's really important. So I think they're the key things to know for this question. Of course, you know that tan of 0, tan of 180 and tan of 360 is going to be 0, and you can just use your calculator for that. And what you should know is that this repeats in sections, so it repeats from here to here to here, but the only thing is you get a complete idea of what tan x is here, but you get this kind of cut off because it starts at 0 and ends at 360. Question 12. We're given a pyramid with a square base, so we'll mark these as being equal, and AB is 5 meters, so they're all going to be 5 here, in meters of course, and the vertex T is 12 meters vertically above the midpoint of AC. So there's the midpoint here, and we're going to draw a line in here to the top, and of course that's going to be perpendicular, which is really important, and we'll just call that x. I think we can get away with. So what we've got to do is calculate the size of the angle TAC. So this angle here. So the first thing I'm going to write is AC squared is equal to 5 squared plus 5 squared by Pythagoras. So I've written the hypotenuse here. AC all squared is 5 squared plus 5 squared. You know, needless to say, this is a right angle here at B because it's a square base. So from that, we just have 25 and 25, which is 50. So AC is root 50. But then 50 can be 25 times 2, so that's 5 root 2. So I'm just going to leave that in that format. And AX then is going to be halfway, half of that. So that's 5 over 2 root 2. Now we're given that TX is 12 because the vertex T is 12 meters vertically above. So we know that TX equals 12. So what does that give us? Well, if we look carefully, we now have AX and we also have this as well as 12, okay? So we can find the angle by using opposite over adjacent. So we have tan of the angle we want, and we'll call it tan TAC, is going to be the opposite, which is 12, divided by the adjacent, which we've got as 5 over 2 root 2. So from here there's many ways you can go. I think what I'm going to do is just try and do the most simple way. And that is, if I've got tan of the angle which I want, tan theta is 12 over 5 over 2 root 2. There's a slight risk that if you put this in correctly in your calculator by forgetting this bracket here, that you're going to slip up and get the wrong answer. So one tip is do the denominator first and then do 12 divided by a and s, or 12 divided by the denominator you've written out fully on your calculator. Some of you are very good at rationalizing the denominator, for example, getting to a situation where you end up with this cancelling because you've got 2 over 2, which is 1. And so that's absolutely fine also. So once you get to that situation, you can then say, okay, tan theta equals 12 root 2 over 5. Now, I personally think this was the simplest way by just decimalising, okay? But once you've got to here anyway, you want the angle, you don't want tan of the angle, so you just want to find the inverse. And again, a whole host of problems here. Make sure you put a bracket around it, because if you don't, then you could get the answer wrong. So I'm going to say shift and then tan, and then I'm going to do 12 root 2 divided by 5, and I'm going to close the bracket. And that gives me 73.58355,963. And I'm going to give the answer to 1 decimal place. I think you could probably get away with giving it to the nearest degree because the lengths are given to the nearest whole number. So I'm going to just say 73.6 degrees to 1 decimal place, and that should be sufficient. Question 13. The number of animals in a population at the start of year T is P subscript T. The number of animals at the start of year 1 is 400. So P of 1 is 400. We're given this relationship here. P of T plus 1 is 1.01 lots of P of T. And we've got to work out the number of animals at the start of year 3. So when T is 1, we have P2 is going to be 1.01 P of 1. And that's nice because we already have what that is. So we can write P2 is going to be 1.01 times 400. And if you think about it, 1.01 is like adding 1%. So that's going to be 404. So we've got to work out P3. So what we need to do is say set T to be 2 now. So that will give us P of 2 plus 1, which is P of 3, which is going to be 1.01 lots of, and be careful, it's going to be 1 less. And we've already got that because it's going to be 1.01 times 404. So I can do that on the calculator. So 1.01 times 404. And that's going to be 408.04. But if we think carefully, it's the number of animals at the start of year 3. So we're going to write 408. And we're just going to write animals. Now, what we can do is just show our workings here, just so the examiner would know what we actually had on our calculator display. So 408 animals for that particular question. Question 14. Y is going to be inversely proportional to x cubed. So that means y is going to be equal to k over x cubed for some k. It says when y is 44, x is a. So from that we can find that k is going to be 44a cubed. It then says, show that y is 5.5 when x equals 2a. Well, what do we do from there? Well, the first thing is we've got this relationship between a and k, and we can put this in this formula here. So y will be equal to k, which is 44a cubed, over x cubed. And x is now 2a. That's all cubed, don't forget. So it's 2a times 2a times 2a, and that's going to give 44a cubed over 8a cubed. The a cubes cancel, and then on your calculator you can just verify that 44 divided by 8 gives us exactly what we want, which is 5.5, and that's the value for y. So we've shown what we needed to show. Question 15. Prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. Well, let's have a look at an odd number. Let's call it 2n plus 1. And then another one, consecutive, don't forget 2n plus 3. I'll prove it for these two, which is by far enough, but for those that want to just learn a little bit more, then I'll do another case as well just to show that it works, and I'll choose 2n minus 5 and 2n minus 3, for example. So if you don't want to watch it all the way through, just skip forward. So for the first one, it says that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So that's 2n plus 1 squared, take away 2n plus 3 all squared, or you can do 2n plus 3 all squared minus 2n plus 1 all squared, doesn't really matter. So we've got 4n squared plus 4n plus 1 minus, be careful, 4n squared plus 12n plus 9. And so we'd have 4n squared minus 4n squared, that's 0. 4n minus 12n, that's minus 8n. And then 1 take away 9, that's negative 8. We can take negative 8 out as a factor. And yes, it's a multiple of 8. Now if you don't like that, you can just write this, and therefore you've got a multiple of 8. Again, some students would prefer to do this. I think the mark scheme sometimes shows it this way round, the bigger one first. And you can work that out for yourself. So for this case here, I'm going to do the one that's larger first, which will be this one, don't forget, because negative 3 is larger than negative 5. So we'll have 2n minus 3 all squared minus 2n minus 5 all squared. That gives us 4n squared minus 12n plus 9 minus 4n squared minus 20n plus 25. And then we're going to have 4n squared minus 4n squared, which is 0, minus 12n plus 20n is 8n, and then 9 minus 25, which is minus 16. Nearly had to use my calculator for that, but 9 minus 25 is minus 16. And then we can take an 8 as a factor there. And you can see that it's a multiple of 8 again. So you only have to do one of the cases. I think some people do this. This is a popular one. 2n minus 1 and then 2n plus 1. So my advice is try a few, just so you've got used to it, because you don't want to freeze in the exam, do you? You want to get full marks. So that's a thorough explanation of that question. Question 16. We're given a shape ABCD, and we're told the shape is made from a triangle and a sector of a circle, centre 0 and radius 6 centimetres. And OCD is a straight line. Okay, and AD is 14 centimetres. Angle AOD is 140, that will be the obtuse angle, and OAD is 24. So we've got to calculate the perimeter of the shape. So I think the best thing to do is to work out this part of the perimeter of the circle, then add 14, and then add this value which we don't know, which we're going to now call x. So I think the first thing to do is to work out how much of the perimeter of the circle we have. So we're going to look at this angle, don't forget, because that's what fraction of the whole circle we're going to look at. And angles in a whole turn is 360, so that angle's 220 degrees. So the circumference of a circle is normally pi times the diameter. But in this case, we have 220 360ths of what it would have been. Okay, so we know the diameter is going to be 12. So we've got 220 over 360 times pi times 12. On the calculator, you can do a bit of cancelling. I wouldn't suggest getting that as a decimal right now, to be honest. I think we can just cancel it down. So we can cancel by 10 and by 10, top and bottom, and then 12s into 36 is 3. So that gives us 22 pi over 3. So that's the first step. What we've got to do now is try and work out the value of x. Well, luckily we're given this angle and this side, and then this angle, and we need to find part of that side, so we can use the sine rule. So we can say 6 plus x divided by sine 24 is equal to 14 over sine 140. So that means 6 plus x is equal to 14 sine 24 all over sine 140. So x is then 14 sine 24 all divided by sine 140 minus 6, just taking 6 on both sides. So the perimeter that we require is going to be that part of the circumference plus the 14 plus the x part, which is going to be 14 sine 24 over sine 140 minus 6. Now, the reason I've done that and not decimalised this and this, all of this, is because I thought it's best to just write down where we are and then do the decimals. I think that's the best thing to do, not only for practice for a non-calculator paper, but I think it's just good practice generally. Instead of just having decimals floating around from the very beginning, it kind of loses a sense of what the problem actually was. So with this, 14 take away 6 is just going to be 8. And now I'm going to put that in my calculator. So I'm going to start off with 22 pi divided by 3. Add bracket, and put a bracket around this, so that's 14 sine 24 divided by sine 140 plus 8. And that gives me an answer of 39.89712.454. Now I want it to correct to 3 significant figures. So first, second, third, and yes, the 9 will change the 8 to a 9. So the answer will be, and I'll just have a a zoom out so we can see how many marks it was. So it was 5 marks, and so the answer we're going to write is 39.9 to 3 significant figures, and that's in centimetres, which is already given here. Question 17. The table shows information about the distances 570 students travelled to a university open day. So what we're going to do is, from that information, we've got to draw a histogram. Okay, so the first thing is we don't know what this axis is going up in. Now, you should know that it's the frequency density, so we'll label that FD. Now, what I do know is the frequency is going to be the area of the bar. So if we have from 0 to 20, then we can go up in a sensible scale. So that's going to be 10, 20, it's going to be here. And I know that's the base. So I've got 20 times something gives 120. Well, that's going to be 6. So I'm going to go 1, 2, 3, 4, 5, 6, and I'm able then to draw my first part of the histogram. Now I'm doing this freehand, and you're obviously going to use a ruler in the exam, but I'm just going to give you a rough idea. So the next one, the area is 90, and I've got 20 to 50, that's 30. So 30 times 3. So 1, 2, 3, and up to 50, and that's going to be my next part. I now want an area of 120, and I'm going from 50 to 80, so that's going to be 60, 70, 80, and it's an area of 120, 50 to 80 is 30, so that's 30 times 4. So that's going to be up to here. Then an area of 140, 80 to 150 is going to be 70, and 70 times 2 would give me the area required. So that's this one. And then 100, so it's 150 to 200, which is 50, and 50 times 2. Okay. So you can just have written this in here, and we'd get these details 6, 3, 4, 2, and 2. Okay, so you can just complete that table. Now we want to estimate the median distance. Okay, so estimate the median distance. Well, if we look at the table, so I want to just have so you can see enough of this so we can enlarge it a little bit. If I write in the figures in the actual bars here, so this was 120, then 90, 120 again, 140, and 100. The median is going to be the halfway point. Okay, so halfway of 570 students, so that's 570 divided by 2, that's the 285th. And as we've done a histogram, an interesting way of looking at it is that we're looking for half of the area in total. Okay, so we start from 0 and we want to capture an area of 285. Well, let's have a look at how we can do that. Well, first of all, we have 120, so that can count towards our area. Don't forget, we've already outlined that the median lies in this bar somewhere. Okay, that's really important. So we can also add the 90 as well, so that's good. So that gives us 210 so far. So what we actually want now is another 75 in terms of area. Now this is really important to pay attention to this particular part, because we already know that the height of this bar is 4, and what we want is a length here, say x. I don't have to know exactly what that length is right now. I just need that length to be something that when multiplied by 4 gives the area of 75 that we require. Okay, so if you're pushed in the exam, it doesn't really matter how long that x line is. When I say that x line, I mean this. It's just to give you an idea of what calculation to do on the calculator. So we want 4 times x to be 75. So 4x must be 75, so x is 75 quarters. So do that on the calculator. 75 divided by 4, that's 18.75. Now, what that means is that 4 times x, i.e. that area of that bar, gives us the 75 that we need to get half of our area, which is 285, and therefore pinpoint what the median is going to be. So can you see what the next part's going to be? Well, if you've already got 18.75 from here to here, we started at 50. So if we want the median distance, then surely that's just going to be 50 plus the value we've just found. So it's going to be 50 plus 18.75, and that's going to give us our answer of 68.75 miles. Now there are going to be a few of you who don't like that particular method. So what you might like is to say, and this is going to be a second method here, what you might like is something along these lines, and that is you've already gotten to 50 because you know it's in, I'll write that a bit better, you know you've got to 50 here because you know that's the start of the class interval that the median lies in. So you've got 50 plus, and you want your bar to have the area of 75, but it's compared to the whole area, which is 120. And then you've got to say to yourself, okay, that's 75 120ths of that class interval, and that class interval goes from 50 to 80, which is 30. So if you did that on your calculator, well, let's do this part and then just add the 50 on. So we'll do 75 divided by 120 and then times by 30. Well, that also gives us 18.75. Add that to 50, you're going to get the same answer, which is 68.75 again. So I hope one of those methods works for you anyway. Question 18. A high-speed train travels a distance of 487 kilometers in 3 hours. So we can convert that to minutes. The distance is measured correct to the nearest kilometre, so that can be 487, so we can go plus 0.5 that way, or minus 0.5 this way, divided by the time measured to the nearest minute, so that will be 180 plus 0.5 for the upper bound, minus 0.5 for the lower bound. And it says, by considering bounds, work out the average speed in kilometres per minute of the train to a suitable degree of accuracy. Well, the first thing we can do is find the upper bound of the speed. So we can find the upper bound. So what we want this to be its most. So that will be 487.5 by adding 0.5. And we want this to be its least. So that will be 179.5 because we'll take 0.5 away from that. So on the calculator, that's 487.5 divided by 179.5. And that's going to be 2.715877437. We're now going to find the lower bound. So in this case, we're going to want 487 with 0.5 taken off. So that's 486.5 divided by denominator being the most, which is 180.5. So that's 486.5 divided by 180.5. And that's 2.695290859. And all you have to do is say to yourself, what degree of accuracy would give the same number here and here? Well, they're both 2 to one significant figure, and they'll both be 2.7, won't they, to two significant figures, because this one here, the 9 would round the 6 to a 7, and this one doesn't have any effect. So what we can say is, and I'll just find the place for the answer, and you can see how many marks it's worth. We can simply say 2.7 kilometers per minute. And the reason we can say that again is because they're both round to 2.7. And what I've done here is I've written my reason clearly as well, which we need. We can say they both round to 2.7. In fact, I'll probably be a little bit more specific. And when I say both, I mean the upper and lower bound. Okay, so that's as concise as we can be, and you must write that reason because it asks for it. Question 19, we have 2x squared minus y squared equals 17, and x plus 2y equals 1. Well, the first thing I'm going to do is rearrange this for x, and I'm going to sub that in A. Of course, you could rearrange for y instead if you want, but I think this will be easier. So we're going to have two lots of 1 minus 2y all squared minus y squared equals 17. I'm now going to multiply this bracket out by itself, so that's 1 minus twice the product, so that's minus 4y plus 4y squared. Of course, if you don't like that, just do a grid. And then you can add these numbers up, and then don't forget, this is what a lot of people forget. They forget that you get the middle ones, which is minus 4y. Minus y squared equals 17. So that's 2 minus 8y plus 8y squared minus y squared is 17. So we've got 7y squared here, minus 8y and the 2. And what I'm going to do now is just get everything on the left-hand side. So I'm going to have 7y squared minus 8y, and then I'm going to take 17 from both sides. And that's what I'm going to be left with, 7y squared minus 8y minus 15. Then I'm going to factorise this. Factors of 15, 5 and 3, factors of 7, 7 and 1. Having a quick look at that, I'm not going to get negative 8y, so I'm going to do the other pair, 15 and 1, and now I can see that you're going to have 7 with the 1. under multiplication, and you're going to have the 15 and the 1 here. So however you do your factorisation is completely up to you. I then see that you've got a negative number here, so we're going to have two signs that are different, and the minus is going to go with the biggest product, so that's going to go here. Some people try and do it in terms of a grid and make the numbers work. That's completely up to you. So if you had a grid and you had y with 1 and 7y with 15, you can put in the signs to make it work to give this answer here. So y is 15/7, or y is -1, and of course that just gives the y values. We want to get the x values as well, so we're going to say when y is -1, we'll put this in b, equation b, this one. So we're going to have x plus 2 lots of -1 equals 1, which means x minus 2 is 1, so x is 3. So we've got x is 3, y is -1. Create a bit more room. And then we're going to look at the other y solution, which is a little bit more tricky. And that's going to give us y is 15/7. Substitute that in equation b. So x plus 2 lots of 15/7 equals 1. So that's x plus 30/7 equals 7/7. And I'm just going to take 30/7 from both sides. So that gives us x equals -23/7, and y will be 15/7, and that's our other coordinate pair. And then for those that are interested, if you plot the straight line here, and if you plot 2x² minus y² is 17, which I won't go into great detail about, you can see that the cutting points here would be as decimals to 3 decimal places, that of -23/7 and 15/7, and here we can quite easily see 3 and -1 here. So that's what they would look like if you actually graph them. So when you get these type of questions, they always can relate to a graph. Sometimes where a circle and a straight line cross, or we can have, in this case, where a straight line crosses a rectangular hyperbola. But don't worry too much about what a rectangular hyperbola is. It's just showing you the graphs behind the question. Question 20. Triangle A is transformed by the combined transformation of firstly a rotation of 180 degrees about the point -2, 0. So -2, 0 is here. And we're going to have a rotation of 180 degrees. So this point here will turn and become this point here. And then we've got this point here. Well, that will go 180 degrees, and that will end up just here. And then the other point will be easy. We've got it here, so it's 3 down. So it'll be 1, 2, 3. It will end up here. Now you can use tracing paper. I have this way that I can do this and show you it rotating, but it just takes quite a long time. So use your tracing paper, and what you do is you put your tracing paper over the whole part here. You do a pencil mark at the center of rotation, and all you do is you put your pencil point there, and you just turn the tracing paper once you've traced out this shape, obviously here. You keep your pencil there and you just rotate it 180 degrees around that point, and this shape will appear here. And all you do is you just take the tracing paper off and create the shape. So forgive me if it's a bit sketchy but I'm doing this freehand. So that's really not a good start. So that will do from there. And so I'm going to call that A dash because I've rotated it now 180 degrees around that centre of rotation. Now I'm going to translate -3, 2. So what that means is that every point just goes back 3 on the x-axis and up 2 on the y. So this point here will go back 3, 1, 2, 3, up 2. So I've coloured these dots in because it's kind of relevant to the next part of the question. So this part will be here. And then the green dot will go back 3 and up 2 and end up here. And then the purple dot here, I'll make it a little bit bigger so you can see them actually. I've just thought some of you will have mobile devices and might not be able to see. So I'll make these dots a bit bigger. Now, this point here will go again back 3, so that'll be 1, 2, 3. So it's going to be here and then up 2. Okay, so I can finish that one off. And then I can just draw my shape again. And obviously there's going to be no gap here, okay? But I'm just trying to explain the dot system and why that's important. It says, and I'm going to call this a double dash because I've transformed it twice now. Now, it says one point on triangle A is invariant, i.e. has not seemed to have moved from where it started to where it ended up under the combined transformation. Find the coordinates of this point. So can you see where that would be in triangle A? What point on triangle A would end up in exactly the same place? And I think you've probably got it, and I'm going to change the colour. Let's have a look what colour we can use here. We'll go with this one. If you started here, then if you rotated it, you'd end up here. And then if you translated that back 3 and up 2, you would end up there. So it's actually the midpoint and of this line here. So the coordinate would be -1, -2, -3, -3.5, 1. Okay, so -3.5, 1. And I'm going to write that down clearly. Okay, so that's my best attempt there to try and explain that question. I hope it helped.